Welcome to First Mile's Climate Heroes. I'm your host, Bruce Bratley, founder of recycling company First Mile. On this show, we meet and learn from the climate heroes who are building solutions right now to tackle climate change. According to the IPCC's sixth report, the world has warmed by around 1.1 degrees Celsius since the Industrial Revolution, and it's on track, sadly, to reach 1.5 Celsius by 2040. And scientists believe that 2023 will end up being the hottest year on record. But how do we communicate the work of 234 climate scientists and 14,000 scientific papers to a public who would rather bury their head in the sand, cross their fingers? And anyway, 1.5 degrees of warming doesn't sound too bad. Help is at hand with my guest, Professor Ed Hawkins, who is a leading climate scientist at Reading University and principal research scientist at the National Centre for Atmospheric Science. He is also creator of the Warming Stripes and passionate about the public's understanding of climate science. Ed, welcome to First Mile's Climate Heroes. Great to have you on the show.
Well, thanks for inviting me.
Thank you for coming on to First Mile's Climate Heroes without any of your usual graphical aids, but I'm sure we'll be absolutely fine. To kick things off, can you give us a potted history of climate science? Because people tend to think it's something that's just been around for a few years, but actually I think, if I'm right, it's been around with us for some time.
Yeah, essentially it's been around for 200 years or more. We often talk about the start of climate science being in the 1820s when the famous mathematician Joseph Fourier asked himself a very simple question, which was, what is the temperature of the Earth? What is the average temperature that are on the surface of the planet? And he did some back of the envelope calculations, and he estimated how much energy we were getting in from the sun and how much that was reflected back into space. And the number he came up with was about minus 20 degrees centigrade for the average temperature of the planet. And of course, then he looked out the window and went, that can't be right. Yeah. So there's something wrong in his calculations. And he thought about it for a while. And after a while, he concluded that there must be something in the atmosphere, which means that it acts as if it was a greenhouse. And that is the first, essentially, that's the start of where climate science began to try and understand why the Earth is a habitable place to live with liquid water at the surface. And around about the same time, scientists also started to realize that the Earth had varied, the climate had varied a lot in the past. They saw the big valleys in the Alps and started to realize there must have been giant glaciers carving out those valleys. And it must have been, much colder at certain times in the past to cause that much ice to grow. And so there are these two problems that were identified to try and explain how the climate could vary and also why the climate now was actually rather warm compared to what it should be. And then it took about 30 years or so, but eventually then we have sort of two scientists in the 1850s, Eunice Foote and John Tyndall, who did some experiments in the 1850s on various gases and identified that water vapor, carbon dioxide and methane were those gases in the atmosphere which were making it act a bit like a greenhouse. Tyndall's experiments were the very detailed ones to really quantify the effect of all of those different gases. And he wrote that the change of the quantity of these gases in the atmosphere will change the climate. And so, all the way back in 1861, when he wrote those words, we have a very clear understanding that changes in those levels of greenhouse gases will change the climate.
And presumably that was presumably no mean feat, because the concentrations of those gases in the atmosphere are not particularly high anyway, and quite a challenge.
So these were laboratory experiments to try and just understand the basic physical mechanism behind the greenhouse effect, which is what the scientists say, the infrared absorption of radiation, or the absorption of infrared radiation by those gases. And you can do that in a high school chemistry lab and demonstrate that very, very clearly. And that helped explain these two puzzles. First of all, it meant that the natural levels of greenhouse gases we have in our atmosphere, we have a level of carbon dioxide and methane and water vapor in our atmosphere, which means that the planet is habitable. And that's a good thing. It means the planet is 14 degrees rather than minus 20. And it also then points to how we can change the climate and how the climate can change both naturally and due to human activities. By changing those levels of greenhouse gases in the atmosphere, you'll either get colder or warmer, depending on what you do to those levels. And so that essentially started to answer these questions and build our understanding of that we have now is that, yes, we are burning fossil fuels, adding greenhouse gases to the atmosphere, and therefore it is warming up.
And then the modern sort of science of climate change, has that all, a large amount of that come from when we've been able to ascertain the temperature and surface temperatures from satellites? Or did we have a sort of modern phase of climate science before we had that sort of remote sensing from space?
It certainly happened gradually. So, I talked about the 1860s. Lots of progress was made through the 1890s when a Swedish chemist called Svante Arrhenius first estimated how much the climate would change if you doubled the level of carbon dioxide in the atmosphere. And that's what we call climate sensitivity now in technical terms, but it simply measures how sensitive the climate is to changing those levels of greenhouse gases. So that was first calculated in 1896. And the next really important milestone, I think, and my personal hero, is an amateur climate scientist called Guy Callender, who in 1938 put together the first estimate of the change in global temperatures. So we had observations of temperature from across the planet, and they were recorded and made available to everyone. And it became very clear in the late 1930s that things were changing and the climate was warming up. And it was Callender who put together the first time series of that change in global land temperatures in the 1930s and said, look, the climate is changing. And even more miraculously, he also put together some of the early measurements of carbon dioxide and also concluded that the levels of carbon dioxide in the atmosphere had also increased. And furthermore, he did, another back-of-the-envelope calculation and showed that he could explain most of the warming that he'd seen in the observations from that change in greenhouse gases. And so all the way back in 1938, we had an attribution of the observed change in global temperatures to an increase in carbon dioxide.
Amazing, a great history which gets us up to date. The bit that's missing from it is you. What's your story, and how did you become a climate scientist and indeed a climate hero?
Well, so I started off actually as an astrophysicist. My PhD is in astrophysics, studying distant galaxies. And I got to the end of my PhD and decided I probably wanted to do something a bit more down to earth. And by a roundabout route, I ended up here in Reading as a climate scientist. And I've been here for a while now.
And so, as I said in the introduction, we've taken away your key, and we're going to come on to the amazing sort of graphics you've done to simplify and explain in a really simple way global warming. How would you explain climate change or global warming in words, and why does it matter?
So climate change matters because our society, our ecosystems are adapted to the climate that we are used to in the past. All our infrastructure is built in the UK to try and deal with the cold weather that we get and the warm weather that we get. When you start changing the climate and you start experiencing temperatures that you've not experienced before, and your infrastructure, your buildings and your roads and railways are not adapted to, then that starts to cause problems. And the same with our ecosystems. They are used to living in a slightly cooler climate. And so when you start changing the seasons and changing the climate, then that causes all kinds of problems for our ecosystems as well. And of course, as our climate is warming, the oceans are warming as well and expanding. And so that's causing sea levels to rise around our coastlines, which means that when we get storms hitting our coasts, the sea level is higher. And so those storms will do more damage. And when we get extreme heat waves, they are hotter than they would otherwise be. And so they are going to cause more problems. And when we get heavy rainfall events, because we live in a warmer world, we have an atmosphere which has got more water in it, more moisture, it's more humid, which means when it rains more. And so we get more intense downpours, which increases the risk of flooding.
Yeah, I think that's probably right, because I can't remember if it was this spring or the spring before where India, I think, had something like 40 days above 45 degrees or something like that. And we had 10 days and thought it was quite bad. And is that what we're going to start to see first?
Absolutely. And, there are limits to what humans can deal with outdoors, and we're approaching those levels, at the moment in certain places at certain times. And so, it will not be possible for people to be outdoors in certain regions fairly soon, at certain times of day. That changes everything. If they can't work outside or whatever that might be, and so those who are vulnerable will experience this most keenly.
Is that by a factor of 2 or a factor of 100, or what's sort of the time scale that we're causing warming versus what nature might cope with?
It almost depends on where you live and what type of nature we're talking about. But it's certainly true that the climate has been both hotter and colder in the past, and the planet has survived. But what we're seeing now is something very different. It's a very rapid change compared to anything that's happened in the past. We've warmed the planet by about 1 degree in 50 years, which is far faster than anything we can see in the historical record, especially since humans have existed. And so, yes, those changes are incredibly rapid, which makes it very hard to adjust to and adapt to, especially for nature. So, what we're doing now is very, very different from anything that these types of systems have had to live through in the past.
First Mile is the UK's leading waste management service. We help over 30,000 businesses reduce their carbon impact with our award-winning range of recycling solutions. Go to our website, which is thefirstmile.co.uk, to get started today. If you're enjoying this episode, don't forget to subscribe. We have brand new episodes every Wednesday. So we have the context, we have the history. You've taken a very specific route with communicating global warming with the warming stripes. Can you tell us, I can see them behind you on the wall, they look fantastic, well, they look terrifying. Can you describe, first of all, for people who are listening so they can get a chance if they're on their phone or their laptop to pull them up as a visual aid, where to find them, and then explain the story, because I don't think it was your first visualization of warming, but then you've sort of really nailed it in terms of a very, very simple way of showing what's happening to our planet.
Yeah, so anyone online can go to the website www.showyourstripes.info, and there you can, it's an interactive website where you can download particular striking visual graphics for the globe and for your country and potentially even your city. And what these graphics show is simply a set of coloured stripes. So for the global picture, it's 173 coloured stripes representing the change in global temperature from 1850 up to the present day. And those stripes are coloured by the temperature of the globe in that particular year. And in the past, those stripes are blues and dark blues for cold temperatures. And as you move up to the present, they become lighter blue and then light red and then very, very dark red right at the end, as we reach right at the end in the present when global temperatures are as higher than they've ever been. And so it's a very simple, striking visual, which you can take one glance at and instantly understand what it represents. It represents billions of individual observations summarized into one simple graphic, highlighting how global temperatures have changed over the last 173 years.
And it's been picked up all over the world. I mean, I've seen it on people's lapel badges, business cards, projected at music concerts. I think I've seen somewhere a mural of it somewhere, and can't remember which country it was in. What's the sort of most sort of extreme places? I think you had it projected on the White Cliffs of Dover once. It's been all over.
So earlier this year, we projected the UK version of the graphic showing how the UK has warmed onto the White Cliffs of Dover. And there's some amazing images of that available. And that highlights, first of all, that yes, we talk about global temperature rise and global warming, but that means every country is warming as well. And so you can drill down on our website to pick out how your country, wherever you live, is warming. And that's really important because it brings climate change closer to home and allows you to communicate and understand that you are being affected wherever you live in the world by this global concept of global warming. You are experiencing those consequences. And these graphics have been used everywhere, as you say. Greta Thunberg's used them on the front cover of her book. We've seen rock bands use them at music festivals. They've even been used at London Fashion Week. A fashion designer called Lucy Tamam made some beautiful dresses out of the stripes and exhibited them at London Fashion Week. More recently, Reading Football Club have put the stripes on their sleeves last season, and so their kit, their home kit and their away kit had the warming stripes on, communicating that message to their fans. And the club were very insistent they were starting on a journey to become more sustainable. And this was one way that they were publicly saying, we need to do better, we need to do more, and to try and bring the fans along on that journey. And so reaching different groups through sport, for example, or through music or through fashion, you can start these important conversations about climate, how it's changing, and what we can do about it to many, many different audiences. And also recently, the Pope got given a scarf with the stripes on as well, which was wonderful to see. Senators in the US have worn them during the State of the Union address, for example. They've been used all over the world in so many different contexts, and it's been brilliant to see people taking this idea and using it to communicate in so many different ways.
And do you have a sort of a hit list of? I always try and write these things. What are the three things that people should do to tackle climate change? And I usually end up with 10, because the first one is talk about it more. The second one is get political with it and try and get the sort of systems to change. And then I end up with another sort of 7 or 8 after that. I mean, do you have a hit list that people say, well, what should I do, Ed, to sort of make a difference?
Yeah, I mean, obviously, talking about it and voting are two near the top of the list. If people want personal actions to take, then changing diet is a big one. So cutting out beef and lamb in particular, or reducing your beef and lamb intake is one big one that you can do. Cycle instead of take the car, or get an electric car, or even better still, cycle more. They're big ones. Turn down the heating at home, get a heat pump if you can, solar panels on your roof if you can. Not everyone can do all of these things, right? I mean, some of these things are quite expensive still to do, and so not everyone can afford to do it. But many of the things you can do will also save you money. So that is also, I think, a key point. But also shop around and shop green, right? I mean, certain businesses are making very specific efforts to be more sustainable. People can choose to give their custom to those businesses rather than ones which are not being so sustainable. And so voting with our wallets, I think, is also an important part of what we can do.
How do you think it's sort of actually going to play out? Because people often ask me about it, and I sort of don't talk about climate change, don't talk about weather even. I sort of say, the thing that's going to be the event that makes people actually go, crikey, we need to do something about this, is when we have mass environmentally driven migration from people living on the sort of the boundaries of a habitable world into, so for example, people coming out of Saharan Africa into Europe because they just can't live in these areas. And I'm sure it's going to happen all over the world. Do you think it's going to be a sort of social phenomena? I mean, never say that as a scientist. I'm a social scientist. So, or do you think it's going to be weather related, or what do you think is going to be the trigger point?
I'd like to believe that there was going to be an event which would trigger a change, but I just don't think that's the case. With all of the extreme weather events we've experienced over the last few years, all over the world, you would imagine that might well be prompting some rather more urgent action, but there's not huge evidence of that. We are still giving out new fossil fuel licenses all over the world, and so that goes against what the IPCC have said about how we can effectively get to keep temperatures to 1.5 degrees above pre-industrial levels. They've very clearly said that we don't need any more new fossil fuel licenses. We've got enough that we can already extract to burn through our carbon budget. And so the government signed up to that aim and yet are not acting in accordance with the science of how we are expected to get to that aim. And so seeing those contradictions is frustrating, I would say.
Scientists have done a huge amount. I mean, it's amazing the volume of work coming out here. So, at the very sort of macro, big level, your job's done. Are you going to put your feet up now and leave it to the marketing people, the communications people, the social scientists?
Partly, perhaps. Certainly, the first exam question we were set was, is the climate changing and is it our fault? And yes, we've answered that exam question and are increasingly moving on to other more interesting exam questions. Like, what does that exactly mean for each individual region around the world? What are the risks that we face? How can we inform society to adapt effectively to the risks that they face? How high do we need to build our flood defences or our seawalls? Or what temperatures do we need to build our future roads and railways to be able to deal with? These are the types of questions which we are now increasingly called upon to try and answer.
And do you think we've got the balance right there? Because the COP26 is very much around, we've got this decisive decade where we can arrest climate change. And if we focus on net zero rather than zero, we might be able to get there. Some are saying we've left it too late. We need to focus our resources and what time we've got onto adaptation rather than preventing any more warming. Where do you sit on that balance? Do you think we've got the balance right or wrong?
It's never too late to act. I think there is a lot of discussion out there which is very pessimistic about our future, and I don't think that's warranted or particularly helpful. Every ton of carbon dioxide we add to the atmosphere increases the warming. So similarly, every ton we avoid reduces that warming. And so it is never too late to act. It's not as if there's some big cliff edge that we suddenly fall off when we go over 1.5 degrees. Right? The impacts just get worse as the temperatures go up. And the politicians have drawn a line in the sand at 1.5 or 2 degrees, but the science says that the risks just increase as temperatures go up. And so we can obsess about these limits, but 1.6 is better than 1.7, and 1.7 is better than 1.8. And so every action we do to limit that rise and get to net zero faster means that those climatic consequences are less severe than they would otherwise have been.
Exactly. And what are you working on then specifically with that? Are you working on future graphics? Any more graphics coming up that we're sort of going to look forward to, or what's the sort of work that's getting you excited in the next 6 or 12 months?
Graphics wise, we're continuing to use the stripes wherever we can, and have lots of conversations with businesses and organisations and individuals about how to use them effectively to communicate. This year we made a whole load of graphics available for different cities around the world to, again, bring that locality aspect to communicating the changes. You can now see the changes wherever you live, and that's really helpful, I think. Scientifically, I think I'm enjoying at the moment thinking about trying to ask questions about what the risks are today that we might face. What is the worst case event that we could experience today that might challenge us? What's the worst storm that might hit us, or what's the worst flooding event that we might imagine is plausible today to help us adapt and design our infrastructure that it might have to cope with. And so that's a very interesting question, I think, at the moment that we have to try and answer all over the world.
And things like, presumably in the UK being sort of an island with lots of coastline, things like sort of storm surges, and if we have sort of a high tide with extreme weather, then that sort of, and we can model these things presumably.
Yes, exactly. So what happens if we get a storm with the strongest winds that hit Dublin, followed by Liverpool, followed by Manchester, followed by Leeds, or follow a certain trajectory where we hit several major cities, causing lots and lots of damage, along with a big spring tide. What damage does that do? With rainfall as well, causing flooding elsewhere. And so, there are these types of events that we could imagine happening quite easily. And so how can we quantify those impacts so we can plan appropriately?
On this show, we're building a Hall of Fame for climate heroes, and we always ask our wonderful guests to leave something in First Mile's Climate Heroes Hall of Fame. So, what or who would it be?
I would put in the Climate Hall of Fame the 1938 paper by Guy Callender and him himself. He did an amazing work as an amateur to essentially kickstart our understanding of how the climate was changing and how the planet was warming using pen and paper. Only, more than 80 years ago, and he deserves great credit for doing that.
And that is superb. And if people want to find out about his work, has someone written a biography of him, or is there a reference source?
There is a biography called The Callender Effect about Guy Callender and his life and what he achieved. The greenhouse effect was called the Callender Effect for a while. He did so much to advance its understanding.
Perfect. We should check it out. Ed, tell me about the Biodiversity Stripes. Is that your creation as well, or is that a colleague who's working on a similar project?
No, they're not mine. So a colleague called Miles Richardson at the University of Derby, decided he would adapt the warming stripes, but make a set of stripes for changes in biodiversity. And he's changed the colours. So it now goes from green to grey through yellow, because we've gone from a very green world to a world which is a lot more grey. And I think it's a very effective communication tool again, because the biodiversity loss is just as serious a problem as climate, and we're not talking about it anywhere near as much. We're losing species, we're losing diversity in our ecosystems all over the world, and that's a very serious problem as well. And so, those biodiversity stripes have been very widely used and adopted by all kinds of people trying to talk about the risks we face from biodiversity loss as well.
Ed, finally, it's been great having you on the show. Finally, I want to talk about another project you're working on, which really caught my attention when I was reading up for the podcast. You're trying to rescue weather. As Brits, I think, would be like, well, we don't want any more of this damn stuff. Don't rescue it. So what's the Weather Rescue Project? And probably give it a plug, since it involves citizens.
It does. So it may be surprising for people to learn that much of our weather observation history, and those observations that were taken 200 years ago or even 100 years ago, have not yet been digitized or transcribed from the original handwritten paper records that they were written on into digital data that we can actually use and analyze today. So if you visit the National Meteorological Archive, you will find a ginormous cavern full of paper records, very detailed weather observations taken across the UK and around the world by our Navy, documenting all kinds of aspects of the weather: temperatures, rainfall, winds, anything you can imagine, recorded in great detail. And those observations have often not been scanned even. They're just the paper records. But when they have been scanned, they haven't yet been converted from those scanned copies into digital data that we can add to our databases to improve our understanding of how the weather and climate has changed. And so we have pioneered an approach where we invite volunteers and citizen scientists to help us out with this challenge. The one we ran a couple of years ago was called Rainfall Rescue, where we invited people right at the start of the pandemic to help us transcribe 5 million observations of rainfall, monthly rainfall amounts that were taken across the UK all the way back to the 1700s, and transcribe them from the original paper records that had been scanned and turn them into invaluable digital data. So that project we completed thanks to 16,000 volunteers and a small group of 8 volunteers who stayed with the project for 2 years, doing all the necessary detailed work afterwards to ensure the data was quality controlled and everything else that needed to be done. And so now we have managed to use that data to extend backwards the official UK rainfall statistics. So we can now produce very detailed maps of rainfall across the whole of the UK all the way back to 1836 with great confidence. And so again, we can look at the extreme events of the past, dry years like happened in the 1850s or wet years in the 1870s, and use those to try and understand, well, what will those events look like if they occurred today, and what would that mean for society if those same unusual weather patterns happen now. And actually, we're just launching our new phase of Weather Rescue. We're focusing this time on a much smaller project, but focusing on data that was taken in Oxford all the way back to 1814. So one of the longest records we have. We're trying to recover observations of atmospheric pressure, which is not something we talk about as much, but is also extremely valuable for understanding how our climate has changed. And so if you visit www.weatherrescue.org, then you can help us out and transcribe these very old observations of atmospheric pressure taken with a barometer in Oxford all the way back to the early 1800s. And that will help us reconstruct the climate of the past.
It's a great experience. It's actually great fun just immediately seeing all these really old transcripts of just I had no idea they existed. Amazing. Ed, we're out of time. It's been absolutely fantastic having you on the show. Thank you for being a guest on First Miles Climate Heroes. It's been super to hear your story and learn all about the warming stripes. Thank you very much.
Thank you.
I'm Bruce Bratley, and you've been listening to First Miles Climate Heroes, where we meet incredible people making an impact to tackle climate change. If you've enjoyed this episode, leave us a review and subscribe to the show. We have brand new episodes every Wednesday.